equations using quadratic sine complex conjugate theorem?
Yes!
First, we need to know our objectives.
Recall how to multiply polynomial equations
Define what QST and CCT is.
and apply what you learned in word problems, boy!
How do you multiply polynomial equations anyway?
So, in multiplying polynomial equations, there are two ways. One is using the lattice method, and two, using the distributive property. For this lesson, we're going to teach you how to use the distributive property.
Okay, so the first thing we do is we multiply the first term to the whole polynomial equation like this. And we do the same thing for every other term. And so on.
Whoa, that's so pet malu!
Now, let's solve!
Yeah!
Form a polynomial equation in factored form, given the roots -1, 1/2, and 3. To get the factored form of -1, 1/2, and 3, we just have to use the addition property of equation. So we would get x plus 1 equals 0, x minus 1/2 equals 0, x minus 3 equals 0. If we put them in a polynomial equation, we would get x plus 1 times x minus 1/2 times x minus 3 equals 0. X equals 1/2 can also be written as 2x minus 1 equals 0. If we did that, our polynomial equation would look like x plus 1 times 2x minus 1 times x minus 3 equals 0.
Form a polynomial equation with rational root coefficients in its lowest possible degree, given the roots 3 and -2i. For 3, it is just x equals 3. But for -2i, since it is a special number, we have to apply quadratic street theorem, giving it a pair, -2i and +2i. The factored form of x equals 3 is x minus 3 equals 0 using the addition property of equation. For -2i and +2i, there is a shortcut to get their factored form. It is x squared minus the sum of the pair plus the product of pair. So the sum of -2i and +2i is 0, but their product is -4i squared. I squared is just -1. So, if we simplify that, we get -4 times -1, which gives us -4. After getting the sum and pair of -2i and +2i, we insert the answers in the formula, which is x squared minus s, or the sum of the pair, x plus the product of the pair. So we would get x squared minus 0 times x plus +4, giving us x squared minus 4. To form a polynomial equation, we multiply x squared minus 4 to x minus 3. And using distributive property, we would get x cubed minus 3x squared plus 4x minus 12 equals 0.
John said the polynomial equation with rational coefficients in lowest possible degree for the roots 1 and 1 plus I times square root of 3 is x squared minus 2x minus I times square root of 3x plus 1 plus I times square root of 3 equals 0. Jesse said the degree of the polynomial should be 3. What did John forget to do? What is the correct polynomial equation?
John forgot to use the pair of 1 plus I times square root of 3, which is 1 minus I square root of 3. If he did use the pair of 1 plus I times square root of 3, he would have been able to use x squared minus sx plus p, s being the sum of the pair and p being the product of the pair. The sum of the pair is 2 because 1 plus 1 is 2 and positive I times square root of 3 plus negative I times square root of 3 is 0. The product of the pair is
1 minus I squared times square root of 9. Because 1 times 1 is 2, I times I is I squared, and square root of 3 times square root of 3 is square root of 9. I is the square root of negative 1, meaning I squared would be negative 1. And if we simplify that, you would get 1 times negative 1 times 3. Then we would get 1 times negative 3. Negative times negative 3 is positive 3, giving us 1 plus 3, which is 4. If we inserted the sum of the pair and the product of the pair, the formula x squared minus sx plus p, s for the sum of the pair and p for the product of the pair, we would get x squared minus 2x plus 4. And if we multiply that to x minus 1 to form a polynomial equation using distributive property, we would get x cubed minus 3x squared plus 6x minus 2.
Hey, yo, thank you for watching our video. Please like.